Hello. This video is intended to help you understand how to do Lab 2, which is measuring kinetic friction values. Now, I'm not going to be going through all of the calculations that are necessary in order to complete this lab. I am only going to be focusing on the Kinovea part, including how to export the data, how to get it into a usable format, etc. So this video is supposed to be used as a supplement to you getting this lab done, but only to cover the Kinovea pieces. So we're going to go ahead and jump into Kinovea quickly. Now I have already given you this video. It's called Lab 2. In this video, I kind of pre-cropped this. You'll see that there's a mass sliding across the floor. What I'm going to go ahead and tell you right here is, if you'll notice, there's a blur right at this edge of the video, and there's a little bit of skew. What's meant by skew is if I go ahead and zoom in on this, grab a mouse so I can be a little bit more official here. But if I go ahead and zoom in, did that right next to the microphone. If I go ahead and zoom in on this, the distance, oh, sweet. So if I hold down Control and then scroll my mouse wheel, this distance here is slightly less than this distance here. And all that means is that there's going to be some camera skew here. Everything that moves over here is going to seem like it's a little bit smaller, I suppose is the way that I would use. So I'm just holding down Control and scrolling my mouse wheel to zoom back out of the video. Now, as per what we do with these videos, is we always have to establish where the best zero position is going to be. So if I go and I'll say, here's going to be my first frame. Note that I don't want my first frame to be too close to the edge of the video. I don't want it to be in contact with my fingers. We'll go ahead and set the beginning of the video to here. And then if I scroll over here, I want it to, I'm going to capture this thing as it stops, just because I think that's fun. So I'll set the end of the video, doing the same process here. So now, if I slow down my play speed, that's interesting. It still includes a bunch of the video I don't want. Huh, I don't know why that moved that. Fascinating. I want it to be about right there. There we go. So now if I hit play, it's just the part of the video where it's moving from roughly here to the end. Now do remember, every time you do video analysis, you don't want the video analysis. You don't want to capture it all the way from the end of the frame, unless it's absolutely essential. For this lab, we really want to only focus on kind of the closer to the middle of the frame. Now I am going to capture it all the way past where it stops, just because I think that that's interesting. I would like to know what the acceleration way out here is. And that's the case. Now you'll also notice that if we zoom in on this, the shape of this mass changes from here to here. If we scroll all the way to the end of the video, this is much more circular. Some of that's just going to be the vibration of the mass itself as it's sliding across the floor. It's going to tilt one way or another, and how it tilts is going to affect its kinetic friction. So it gives a very realistic view of what happens when we have things sliding. Sometimes there is vibrations. Now what we do to start this is we're going to go ahead and put, I'm not going to put a point right here. Go ahead and grab my hand tool again. I'm going to scroll back to closer to the beginning here, and we'll zoom in, because I like zooming in. Once again, hold down Control. Now just for reference sake, I'm going to put a point in the center of this circle, in the center of this circle, and then I'm going to try doing a point right in the middle of the crease here. You'll notice we don't really have a center point here, and it does kind of spin. I'm going to right click on this. I'm going to go to configuration, and I'm going to put this as circle 1. I can set this color red, hit apply, and then I will do tracking, start tracking. Right click on this one, configuration. This will be circle 2. I'll set this one to a green color, just because I like green. Hit apply, right click on it again, start tracking, and then go to my last one, configuration. We'll call that one center, and I'll pick this one as a darker blue color and hit apply, and then do tracking, start tracking. Now you probably won't need to have all 3 of these points, but I think it's important that based on where you select your points, sometimes it's helpful to do multiple points at a time, just because some of your points are not going to track well. And as long as you can get 1 point to track, that's the nice feature, especially in a video like this where there isn't a real nice center. Oh, did I hit start tracking on this one? No, I'm going to right click. Oh, no, I did. Okay. So I go ahead and hit play. Now, you'll notice it went real slow. And here, my blue marker did not stay in the middle here. In fact, none of my markers really did stay in the middle here. So I'm going to scroll back a bit, try to see where I lost them. Yeah, here, these are both roughly in the middle. Roughly in the middle. Starting to diverge, the red one. The green one's still pretty much right on point. But here the blue one's just completely off. As is the red one. I'm going to scroll back a little bit and try to do a little bit of fine-tuned adjustment on this to get my marker to be roughly in the right place. So here at this frame, my red marker is not where I want it to be. So I'm going to zoom in. I'm going to go ahead and click this, stop tracking. Oh, actually I'm going to 1 frame back. Click on this. Oh, that's already got that. Ah, no. I would like to delete you. Accidentally created a new one. We'll take this one. I'm going to move it to roughly the middle. I'm also going to go to this one and do stop tracking. Roughly move it to the middle. This one's okay. I'll go ahead now and do start tracking again for both of these points. You'll notice that it's going to require, I'm going to have to delete this point from here to the end of the video. So, I don't think you can just delete it from here to the end of the video. Yeah, because that just deletes it out of the whole thing. I'm going to go look that up real quick. Okay, so well, apparently there's no way of doing this. That's nice. Huh. Oh, that's too bad. I suppose that's free software issues. So then I guess that I can't just fix it that way. I'm going to go ahead and delete this point entirely. And then just try retracking it from here. So once again, pick in the middle, pick in the middle. We'll set this one to be circle 1 again. Set it to red. Apply. Go ahead and start tracking. We'll go ahead and set this one to center again. Set it to a darker blue just because I like darker blue. And then go ahead and hit apply and start tracking. Now here I'm going to just parse through one frame at a time until I know that they're going to be roughly in the place I want them to be. Here I can see that the red one's already starting to jump off. So I'm going to move that. Oh, not that way. Move it right there. And then hit tracking. Move this blue one. Back. Track. Track. My red one's getting a little bit off. Blue one's getting a ways off. Let's reset those. Sometimes changes in lighting can do this. I really would have helped myself out a lot more by having actual markers to track rather than it's going to create some weird jumps in my plots, unfortunately. Every time you adjust it like this, you're going to get some weird jumps. And my grain is just completely off at this point. So we'll go ahead and zoom out now. I feel like my blue and my red, I tracked the most critical regions. Now if I go ahead and hit play, now stepping back through the video, it's going to track them in reverse. You'll notice that my red marker is completely off, but my blue marker is roughly where I want it to be. And there it is. So that's my whole video. Now if I go to my tools, linear kinematics, you'll notice that the speed should be roughly equal for all of them. The center line is a little different. That was the one that I trusted the most. I'm going to go ahead and look now at acceleration. I don't really trust my curves to be so super great. Oh, I forgot. Oops, I forgot to put a calibration line in here. Should probably do that. So go ahead, zoom in. Nope, I'll draw the line and then zoom in. So here we'll have it go from here to here. Having a really long calibration line means that if you're off by a couple of pixels, it usually won't affect it too much. We'll need to make sure that we're in the center as much as we can. Just try to increase that accuracy. So this is a ½ meter long. So if I right click on this, calibrate it, this I'm going to set at 0.5 and then set that straight to meters. We'll say sure that this line defines the horizontal axis, although I'm just going to use generalized acceleration anyways. So now if we go into linear kinematics, this should be a little bit more accurate. Now you'll notice that mine tends to jump up and down. Some of this is just because I was adjusting the points. the points did not track that well. If I were to do this video again, I would need to have better lighting. I think that was the issue that I experienced here, but when I recorded this video, I didn't have a lot of lighting. Now you'll notice my data points kind of jump up and down. Acceleration here is roughly 3.5 to 4 meters per second, and then it decreases with time. Now, even with the green line, which tracked fairly well for most of it, you're going to see some oscillations out of this. Just because, as I mentioned, it comes in and it kind of vibrates a little bit before it flattens out. Here at the end, at the very end of the video, it's supposed to go to 0 because it actually does come to a stop, but this might have been just before it came to a stop, because then all of these three go to 0. If we go look at speed here, yeah, it's just barely coming to a stop right at the end. So yeah, if I really wanted to get that 0 acceleration, I would need to have it at a point where the speeds themselves were at 0 for a while. These are fairly flat, but you'll notice that the oscillation oh, just gonna keep clicking on stuff. The oscillation is a little wonky, but you should be able to get a graph that looks something like this. Now, what you can do here, I cut off the very beginning of this video. You'll notice how it kind of increases, well, increases in magnitude, decreases in value at the very beginning. I don't really trust these all that well at the beginning. So for me, I would only really consider from this portion on. This is getting really close to the end of the video, so this part right here represents something else that's kind of unique. It's not a real nice way of calculating this, but it does show some variation in here. Each of my points that I grabbed show some variation. For your file, I wouldn't necessarily expect you to track multiple points, because what's going to end up happening is I'm going to have to pick one. And for me, the blue one was the one that I felt like was the closest, but even then I had to keep adjusting it slightly as it tracked in order to keep it on bounds. I could just keep retracking this until I get something that's real nice and smooth. But for the sake of this lab, with this being a little bit not as well lighted as I would like, I will accept the oscillations in this lab. So now to this, you're going to save to file, export your data. What you'll have to do is you're going to have to calculate using one of these three curves, or whatever curve you come up with. You're going to have to calculate what is the net force that is being exerted on this mass. From that, you can calculate and graph what your friction force is, and then from that, which is a calculated value, and then from that calculated friction force, you should be able to calculate what the coefficient of friction is. And the coefficient of friction is going to end up looking very similar in shape to this. And then you'll have some questions that you need to answer as far as how you feel the video went. So that's lab 2.